Okay, today we're going to be talking about gas stoichiometry. So, bringing back our mole island map as we've done before, we already had mass A, mole B, mass B from previous chapter. Now we're adding two more islands, and that's going to be gas volume A at STP and gas volume B at STP, plus these information on these arrows. So, when we conduct gas stoichiometry calculations, it is very important we do the following. The answer should have the same number of significant figures with what we started with, and our answers must have a unit and a compound following the number answer. And do some gas stoichiometry practice problems. Problem number 1 says how many grams of CaCO3 will be needed to form 4.29 liters of CO2 at STP. Now you see how this problem says at STP? That means we're going to be involving gas on our mole island map. If it does not mention anything about STP, we're not going to be associating that gas option on our mole island map. So just like we've done before, we're going to circle what we're given, underline what we're solving for. We are given 4.29 liters of CO2, and we're trying to find grams of CaCO3. Now 4.29 liters of CO2. Liters, that's going to be volume, but this is going to be gas because it's STP. Gas volume A. And the problem is asking us to solve for mass of a different compound, so we're going to end at mass B. So now that we know where we're starting with and where we're going to, let's go ahead and rewrite what we circled. And start doing our steps with our mole island map. The first step says if we're starting at gas volume A, is 1 mole is going to be on the top and 22.4 liters is at the bottom. In this step, liters cancel. If we're following along on our mole island map, our next step is our mole ratio step. The compound circled is going on the bottom, which is our CO2. Compound underline is on the top. And looking at our balanced chemical reaction, CO2 there is no number, so it's going to be 1. CO3 there is no number, so it's going to be 1 as well. And CO2 cancels. And our last step to our mole island map is molar mass is on the top and 1 mole is on the bottom. So we're going to have to solve for the molar mass of the compound that we have. And if we look at our work, the compound that we have is CaCO3. So let's go ahead and find the molar mass of CaCO3. So looking at our periodic table, calcium's atomic mass is 40.078. We have 1 of them in the compound. Carbon is 12.011. We have 1 of them in the compound. And oxygen is 15.999, and we have 3 of them in the compound. So when we plug this into our calculator, we get 100.086 grams per mole, and that number goes in the top. And in this step, we got moles cancel out, so we are good to calculate it. So all we're going to do is we are going to multiply the top, divide the bottom, multiply the top, divide the bottom, multiply the top, divide the bottom. And when we plug this into the calculator, we get 29 times 1 divided by 22.4 times 1 divided by 1 times 100.086 divided by 1. We get 19.168. But again, we have to round to the proper number of significant figures. We start with 3 sig figs, so we get to end in 3 sig figs. So 19.1, the 6 tell me the 1 goes up, so our final answer is 19.2. We solved for grams of CaCO3. And that is the final answer for problem number 1. So go ahead and do problem number 2 on your own. When you have your, pause the video, and when you have your answer, press play. And here's your answer. And that's it, guys. Thanks.